the specific application that we're interested in with this project is autonomous radiation mapping. The advantages that have been focused on are really to do with the trying to keep people away from radiation thing. But actually, while that's good and necessary, we think that people have underestimated the potential third benefit of this, which is that robots, because they have the ability to crunch the data in real time and to do physics analysis that the human brain's just not capable of, are actually capable of doing a much better job than a human.
The robots have a variety of different odometry sources on board. So on top you can see here a series of fisheye cameras, so that they're able to give us a kind of visual odometry, laser obviously, and leg odometry. And the primary piece of work that we've done and contributed to this competition, but also developed and integrated for the project, the radiation project, has been fusing all of these different sources of odometry. So here is our laser mapping system. So this is a handheld variant that we had in place about a year ago for a data set that we collected. And you can see the laser being used to incrementally estimate the motion of the handheld system. And this gives a very low drift and high accuracy odometry system.
We've integrated this yellow Compton camera, which has a very, very high sensitivity, very high resolution, and is a good fit to the most demanding environmental and waste assessment applications. On the far side of the yellow detector is the ORI Rooster payload that's doing mapping using the V-lens algorithm that Morris described. And then that system is communicating with the smart radiation system, just sending periodic map update messages and a stream of location data. The smart radiation system is integrating that with the individual photon observations from the yellow GG detector to work out what's going on in the environment. So what we've tried to do in this specific project is to make a subsystem, a reusable subsystem that is packaged, a detector with some autonomy that converts the very specific data and the subjective data that comes out of that specific detector into something which is objective and sufficiently abstract that a robot can deal with it without needing to know precisely how that specific sensor was used to produce that specific result. What that means is that someone who doesn't necessarily understand how radiation measurement works can still take this system and integrate it with their robot to get some specific task complete, and they can be sure, and their end user can be sure, that the computations behind that are robust and that the robot is achieving its specific quality objective, rather than simply going and getting some data which may or may not turn out to be sufficient when we analyze it.